Welcome to a short little video on simplifying rational expressions, part 2. To simplify a rational expression means to reduce it until you can't reduce it any further. It requires finding common factors in both the numerator and denominator and dividing them out. Examples involving fractions will be shown first, and then we'll get into some that have algebra. Okay, so in the first one, we're going to simplify and state the NPVs where required. So the first one, again, just a fraction, so we don't have to worry about any NPVs. Let's see what goes into 125 and 360. Well, I know that they're both divisible by 5 because of what they end in. So if I divide the top by 5, and I got to do the same thing to the bottom. 5 goes into 125 25 times, and 5 goes into 360 72 times. Now, the other things that go into 25 are 1 and 5 and 25. Other than 1, none of those things go into 72, so that is as simple as this gets. Okay, let's take a look at the next one. Notice that we have 9 on the top. 72 is also divisible by 9, so I'm going to divide them both by 9. 9 goes into 9 once, and 9 goes into 72 8 times. Okay, x goes into x squared, so when I divide two things with the same base, I subtract the exponents. So x goes into x squared just once, so that leaves me with x to the first, and y has no 1 to go into, so let's simplify the top. So we have a 1 times x to the first, which is just x to the first, or x, and on the bottom we have 8y. Okay, good. Now that's as simple as that gets, but this guy has variables in the bottom, which means we have to find the NPVs. We have 72, xy can't be 0. Divide by 72, so we just get xy can't be 0. So in this case, because I have two factors, each one has to be set not equal to 0. So x cannot be 0, and y cannot be 0. And those are your NPVs. Notice again that my denominator is a monomial, so it doesn't surprise you that this is the answer. Okay, in part C, it's already been factored for you. So if you'll notice, you can cancel out the x plus 2's because they are binomials that are identical on the top and the bottom. Okay, so then that leaves me with x over 5. That cannot be simplified anymore. So that part's done. Let's find our NPV. Remember, for the NPV, we only look at the denominator. So we have 5 times x plus 2 cannot be 0. I divide both sides by 5. And I get x plus 2 cannot be 0, because 0 divided by 5 is 0. And then I'm going to subtract 2 from both sides, so x cannot equal negative 2. And that is the NPV for this question. Okay, next one. 16k plus 72 over 40k plus 24. Well, I know that the top, I can divide them both by 8. So I'm going to factor an 8 out, so that becomes 8 times 2k plus 8 goes into 72 9 times. I can also factor an 8 out of the denominator. So 8 goes into 40 5 times, and 8 goes into 24 3 times. Now I have an 8 on the top and the bottom being multiplied, so those cancel out. And I'm left with 2k plus 9. I'll write that properly. 2k plus 9 over 5k plus 3. Great. All right, NPV. So 40k plus 24 cannot equal 0. 40k cannot equal negative 24. K cannot equal negative 24 over 40, which simplifies to, let's see, 4 goes into both of those. 8 goes into both of those, so that would be negative 3/5. So k cannot be negative 3/5, and that guy's done. Okay, okay, denominator's factored. Is there a way I can factor the binomial in the numerator? Well, I guess it looks like I can factor that guy too with a GCF, greatest common factor. So on the top of that guy, I can factor out a 5. 5 goes into 5 once. 5 goes into 20 4 times. I can factor a 2 out of there, so that becomes 2 times m minus 1 times 2m plus 5. And lo and behold, it does not look like I have anything the same on the top and the bottom. I can't cancel this 5 with this 5 because this is a binomial, and this is a monomial. They don't go together. You can only cancel binomials with other binomials. Okay, so let's look at our denominator to find our NPVs. Okay, 2 doesn't matter because it's always going to be 2, so we only worry about ones with variables. So m minus 1 cannot be 0, or m cannot equal 1 if I add 1 to both sides. And 2m plus 5 cannot equal 0. So if I add 5 minus 5 from both sides, and I get 2m cannot equal negative 5, and then divide by 2. So m cannot be negative 5 halves, or 2.5 again. Okay? Good. So last example, and then you guys are off to do some work. So again, the numerator can be factored, so I can take out a 6p, and I am left with p squared minus 4 on the top. On the bottom, I have 2p plus 1. I can factor out a 5, and I would be left with p plus 2. Okay, because 5 goes into 5p once, and 5 goes into 10 2 times. Now, if you notice, this here again is a difference of squares, so we can factor that to conjugates. So that would equal 6 times p plus 2 times p minus 2. And then I have a 5 times p plus 2 times 2p plus 1. Remember, multiplication, the order that you do things doesn't matter. All right. Now I have a p plus 2 on the top and a p plus 2 on the bottom, so I can cross those guys out because they're the same binomial. I'm left with 6 times p minus 2 over 5 times 2p plus 1. And that's as simple as that gets. Now, I'm going to find my NPVs, but remember, you always find NPVs for anything that was originally in the denominator. So we have 2p plus 1 can't be 0. So I'm going to minus 1 from both sides. 2p cannot equal negative 1. And then divide by 2. So p cannot equal negative 1. Negative 1/2. Okay, we also had the original p plus 2 cannot be 0. And I'm going to subtract 2 from both sides. So p cannot equal negative 2. Okay, so those are my NPVs. That is my simplified expression. And that was all kinds of fun. All right, page 229, let her rip. And don't forget to show your teacher when you're finished.